Time is the one constant in life. It always moves forward and never backward. However, in classic physics equations, the direction of time does not seem to matter. How can this be? Well, my name is Theorai Gesipe, and I will be explaining this through the concept of entropy and the arrow of time.
How does one scientifically determine the direction of time? I know time has passed because I'm a junior in high school and have reached finals week. We also know from observation that when you drop an egg on a hard surface, it breaks. However, those pieces never come back together to reform the egg. The same goes for dropping ink in water. Once the ink is dropped in the water, the process cannot be reversed. However, a scientist trying to study this concept would be interested in using physical processes to understand time. Physical processes obey laws of physics, but here's the problem. Time is reversible in all equations of classical physics. So what does this mean? When Newton developed the equations of motions, he was interested in following the motions of bodies. Take, for example, Newton's second law. It can be used to calculate the position, velocity, and acceleration of an object when it's subjected to force, but it runs backwards. If we replace time by the negative of time, we get the same equation. So what determines the direction of time, and how do we know how physical systems evolve as a function of time? This leads us to the concept of thermodynamics. The first law of thermodynamics states that the total energy of a closed system is constant. So in theory, if you have one hot object and one cold object in a closed system, the cold object could get colder and the hot object could get hotter, because the total energy of the system would remain constant. However, we know that's not the case. We all know that if you hold a cup of warm coffee in your hand gets warmer and the cup gets colder. This is explained by the second law of thermodynamics developed by Ludwig Boltzmann in 1877, which used a concept called entropy. So what is entropy? Entropy is a state of disorder, and the more disorder, the more entropy. Gases have a higher entropy than liquids, and liquids have a higher entropy than solids. Boltzmann postulated that a system moves in a direction that will result in an increase in the system's overall entropy. This is why the heat moves from a hot object to the colder one, as by increasing the heat of the colder object, it increases the overall entropy of the system. Higher entropy results when the heat is uniformly distributed throughout the system. So the arrow of time points in the direction of increased entropy. But how long can entropy increase? Eventually, the entropy of the universe will have reached its maximum, and the universe will be the same temperature everywhere. This is what is known as heat death. What happens then? Scientists are still not sure. Some say that the arrow of time will reverse and we will see a big crunch where everything starts to collapse. Others say that because the universe is so large, we will never see a heat death. But what does this mean for the origin of the universe? The universe started as a high dense state with very low entropy. So it all did start with the Big Bang.